Assalamualaikum dan selamat sejahtera. We are from Group L will explain a journal titled Application of Evaporative Cooling on the Condenser of Window Air Conditioner. There are 5 group members in our group. First, Muhammad Hazrul Hanif bin Mausin will explain about method of performance analysis. Second, Muhammad Iqbal Hisham bin Kamaruddin will explain about schematic drawing and explanation. Muhammad Azari Ramadani bin Misno will explain about introduction and basic principle of the system. Alish Kalisha binti Rusazali will explain about suggestion of system improvement, and Tan Bun Sang will explain about performance calculation of the system.
My name is Muhammad Azari and I will explain about introduction. So the main objective of this slide is to improve the performance of window air conditioner in extremely hot weather condition up to 50 degrees Celsius. So the main problem is at high temperature, the efficiency of air condenser drops, leading to increased power consumption and decreased cooling performance. So for the solution, incorporate evaporative cooling to enhance the heat transfer and reduce power consumption. Basic principle of the system. Usually, conventional air conditioner works by expel heat from indoors to outdoors via the condenser. The condenser dissipates heat to the outside air. In extremely hot conditions, this process becomes less efficient, causing the system to work harder and consume more power. So to overcome this problem, we introduce evaporative cooling. So the main concept is evaporative cooling uses water evaporation to cool the air before it passes over the condenser coil. So mechanism, uh, as water evaporates, it absorbs heat from the air, reducing the air temperature. There are two main designs for this system. First, evaporative media pads. These pads are installed on the side of the air conditioner. They are made of a material that retains water and maximizes the contact area between air and water. For the second one is water circulation system, comprise a small pump, water tank, and pipes that deliver water to the pads. So functionality, water spraying. Water is continuously sprayed onto the evaporative media pads. Air cooling. Incoming hot air passes through the wet pads, where water evaporation cools the air before it reaches the condenser coil.
I am Hazrul, want to present about method of performance analysis for air conditioning. At first, we look at the pH diagram graph analysis, which as have pressure and enthalpy was plotted visualized by refrigeration cycle. And at first point, we have compressor. At compressor, it will make the pressure will high, and next we go to the condenser. At condenser, it will change from gas to liquid, and it will at same pressure. And next we go to the expansion valve. At expansion valve, it will detect the heat and make the pressure and the temperature at lower point. And next we go to the evaporator. At evaporator, it will change the liquid into gas at the same pressure. Next we go to the temperature analysis. From it, we take the temperature at compressor and condenser exit to assess the effect of evaporative cooling. And from the reduction in condenser temperature, it will indicate more efficient heat rejection. For second, pressure ratio. It will take the compressor and condenser exit to calculate the pressure ratio. And from the reduced pressure ratio, it will take for indicate the reduced compressor workload. For power consumption, from the electric current draw, we can access the energy consumption, and from the reduction in power consumption, it will show the evaporative cooling show decrease in power consumption. And last, from the coefficient of performance, which is COP, which we calculate QC over W, which is QC is cooling capacity and W is work input from the power consumption. And from the increase in COP indicate enhanced overall efficiency.
These two tables is show the thermodynamic properties of refrigerant and conventional and ever evaporative evaporative runs especially based on data from the journal. Actual power consumption can be obtained by using equation 1 since the voltage, current, and cost data are known. Mass flow rate can be obtained by equation 2. Cooling capacity capacity and COP can be obtained by using equation 3 and 4. In equation 4, subscribe 1, 2, 3, and 4 stand for exact condition for evaporator, compressor, condenser, and capillary tube respectively. The result of calculation for power consumption, mass flow rate, cooling capacity, refrigeration effect, and COP are shown in the table of certification of air conditioner. The results show power consumption decreased about 50% and cooling capacity increased about 33%. Mass flow rate increased 12% and refrigerant effect increased 90%. The COP, which is the most important parameter, increased about 55%. That indicates that by employing evaporative cooler, not only power consumption decreased, but also cooling capacity also increased. This slide is showing the experimental result of the test that we need to use to do the calculation.
Okay, now I will explain about evaporative cooling integration system. For the concept, evaporative cooling cools the air before it passes over the condenser coil. This is achieved by adding cooling pad on both sides of the air conditioner and injecting water onto these pads. Okay, it means that when the air passes through the both of the media pad, it will remove the hot air from outside and cool air that pass through the media pad will flow to the condenser. So the condenser didn't need to high power to remove the hot air. For the evaporative media pads, the cooling pads are made of cellulose-bound cardboard structure that increase the contact area between air and water, it promoting efficient evaporation and cooling. For the evaporative cooling pad, which is media pad, it made up of cellulose or synthetic material and it have honeycomb structure. For the structure, it have honeycomb design to improve the efficiency of the evaporative cooling process. The function of this media pad is water is distributed over the pad and as air passes through them, the water evaporates, absorbing heat from the air and thus cooling. We can see from the diagram, water will inject to the media pad to keep it wet from absorbing hot air outside. And it have water tank to store the water, so we just need to top up the water. For the maintenance, we just need to keep the media pad clean, and if we don't keep this media pad clean, it can reduce their effectiveness over the time from mineral that from the water.
Assalamualaikum. My name is Elis Kanisa. I'm here to present suggestion for system improvement. First, upgrade the evaporator by installing a zoning system to divide each room into separate temperature zones, each with its own thermostat and dampers. This allows more precise control over indoor temperatures and can reduce energy consumption by only cooling occupied areas. Second, upgrade on the expansion valve. By using an expansion valve designed specifically for the application can optimize performance in both heating and cooling modes. These valves are engineered to accommodate the distinctive features of heat pumps, such as reversing refrigerant flow and operation at different temperature differentials. Lastly, exchange from basic air conditioning system to combined system incorporating a basic AC cycle and ORC or TCO2 module. From the basic air conditioning system, replace the normal condenser to ORC module with internal heat exchanger IHX, saturated vapor from the turbine directly to produce electricity. After dry expansion, the exhausted low-pressure vapor is condensed in the condenser with the saturated liquid pumped to the IHX to complete the cycle.